My name is Tim McElwee. I'm a construction engineering major, graduating May 2014. My role for this project was I was the project manager.
Hi, my name is Maria Volkina, and my major is construction engineering. And the year I'm graduating is May 2014. My role for this project was a lighting designer.
Hello, I'm Gustavo Maldonado. I'm a construction engineer student. I'll be graduating in May of 2014. My role for this project, I was a solar analyst.
Our senior design project is the Green Energy Challenge. It's a student competition where universities across the United States compete. It's put on by Electri International and the National Electrical Contractors Association.
For the competition, we had to choose a student union building. We chose Kearney High School, which is located in San Diego, California.
The building was built in 1955 and needs to be retrofitted. It does not have any insulation or air conditioning. The light is super inefficient.
The proposal we will discuss was prepared for San Diego Unified School District. This is a 3D model of Kearney High's gymnasium. The building is approximately 20,000 square feet. It has an attached wrestling room, locker room, and bathrooms. The gym has an architectural ceiling which is very important to the client. One of our goals was to keep the aesthetic appeal of the gym.
Aztec Energy is proposing to retrofit 135 fluorescent lights with only 83 LED lights, going from approximately 1,500 watts to 9,300 watts, which will give us roughly 40% in savings. As you can see in this picture, the lights are mounted at inconsistent height, which makes lighting distribution uneven. These fixtures are large but do not provide sufficient lighting to meet the requirement of 50-foot candles. This picture shows proposed layout for the lighting and all of the sensors. For the gymnasium area, we are proposing solar tubes, which will provide natural lighting. 36 high bay fluorescent luminaires will be replaced with just 12 high bay LEDs. The fixtures will be mounted at the same height of 22 feet for even light distribution. We are also providing photocell sensors in every room there is natural lighting. Such rooms are shown in the picture with windows. Every room will have occupancy sensors and dimming controls. We are also replacing exit signs with LED exit signs and emergency sign lights combo. With this lighting retrofit, our goal is to achieve at least 40% in savings.
A detailed analysis of renewable energy sources was provided to the owner. At first, a wind analysis was performed to see if we could add a wind energy system. It was determined that it was not. Another source was geothermal. Due to the cost of the equipment, it would increase the school's budget. So therefore, we won't propose it. The last type of renewable energy that was analyzed was solar. According to suncalcs.com, we were able to determine that solar would be the best type of renewable energy. The gymnasium sits in the perfect location. Therefore, we will be proposing to install a photovoltaic system on top of the roof. The roof of the gymnasium cannot be modified. We will put the PV system to the adjacent roof of the gymnasium, such as shown in red. Here, we can see a layout of the solar panel arrays. We will be proposing to install 80 solar panels as shown. The panels will be connected to a combined box that will be then fed into an inverter to change DC to AC. From the inverter, it will go to a disconnect and then to a meter. And finally, the main switchboard. As shown on the table, here's a breakdown cost of the PV system. Solar panels are $1 per watt, inverter 30 cents per watt, labor $1.95 per watt, and miscellaneous such as material, conduit, and meter connections 64 cents a watt. Our total cost per watt is $3.89. We are installing 80 solar panels. Our total cost will be $107,364. Lastly, here's an estimated monthly production of the solar panels, which is 42,000 kilowatt hour for the entire year.
High's campus is currently on only 4 utility meters. This cannot provide accurate information about the gym's energy consumption. We are proposing to install 3 meters, one to monitor the gym, one to monitor the locker rooms, and one to monitor the solar output. We will use Leviton Series 2000 submeters and controllers. This information will be displayed on a monitor at the entrance to the gym to educate students about their energy consumption. The display will look similar to the dashboard shown. A full construction estimate was provided for the upgrades. This includes pre-construction, design, general conditions, and construction estimates. The total project cost is $307,000. Labor rates and productivities were used from NECA's 2013 Labor Unit Manual. As shown in the figure, construction totaled $218,000. The schedule for the project was broken into 3 phases: gym, locker rooms, and PV array. The phases were stacked in order to reduce the construction duration to the summer. Construction begins June 16th and ends August 14th. By keeping construction confined to the summer, it will reduce traffic during construction, keeping students and staff safe. The critical path of the project runs through the gymnasium lighting, as shown. This is the site logistics plan for the project. Laydown will be confined to the north of the gym. A flagger will be stationed at the entrance of the delivery route, as shown in purple. The dashed yellow line is a pedestrian walkway around the perimeter of the construction fence. The flagger will assist students and staff in crossing the delivery route to the adjacent parking lot. Student safety is of utmost importance to this project. That concludes our presentation for Capstone and the Green Energy Challenge.
The results will be out in July, and we're very confident that we're going to place.
Thank you very much for watching.
Thank you.